Hi guys, welcome to part 17 I believe of our Formatables Refactor. Slightly never ending this refactor, but well, in a way, we're getting close to the end. So last video we were dealing with the streaming properties. I ended up having to stop halfway while I was doing the analysis because as usual I was struggling to concentrate while talking. The problem we'd end up having was actually quite a trivial problem. It was merely that this is actually a really annoying problem as well. Streaming properties transform. The problem is that for whatever reason in C++, if you create a class inside of a CPP and that class happens to have the exact same name as some other class, it seems that sometimes they get mixed and matched. In other words, the compiler just determines that there's two of them and chooses one of the two. And you end up with some really random exceptions that are very hard to make sense in the debugger because it's actually some other code that's executing, not this code. So the solution to that problem is to put an anonymous namespace to generate a unique name, or to use an inner class or something that's actually quite distinct. It's quite an annoying problem. We've been bitten by this quite a few times, and every time it happens it's always surprising. But anyway, we solved that problem, and then after that it was fairly straightforward. That problem was hard to solve, but after that all we needed to do is to populate these guys here, improve the logging slightly, and then we did a number of commits, as you can see here. So we went through a series of commits to hook up the streaming properties transform, and then we started removing it across the board, and then we had to go through the pipeline to try to figure out how to give those properties to the places where they're going to be used, and that was done. So with that we are now moving over to the next class, which is the C++ standards. Now this again is going to be data driven at some point, but for now of course it's not. So we just have to understand what we need to do here. So at present we have one of these guys per model. Now the problem with this is that you can't really call it C++ standards because of course that's going to be presumably well, C# models can't have a C++ standard for starters. So I mean, whilst we need to do some hackery here, we also need to make it not too hacky. So perhaps what we can do is we can do something like a technical space version, maybe, because we already created a technical space, and I think if we create a technical space version, I mean clearly this is still a hack, of course, but it's just less of a hack than it would be if we just literally put C++. It's just so we don't get confused. So what we're going to do is see if we got enough space somewhere around here. Perhaps if I move this guy here. So if we create something like technical space version, Portuguese keyboard, technical space version. So version of the technical space to use. And now this is where the hackery starts to get nastier. Is of course, as you can imagine, versioning for different types of technical spaces are completely different, and that's why this is really something that should be data driven, but there you are. What we'll do is we will just do something like Cpp. Well, actually I think we could probably just copy the exact same names, Cpp 98, 11, 14. So so you can see here so there's a famous saying, I guess, yeah, I wonder, we don't seem to have 2003. Okay, maybe we don't need it. There's a famous saying in computer science that you should make invalid states unrepresentable, which basically in this case means that it should not be possible for you to have C# as a version and then have a technical space version that is does not match, if you see what I mean. And also we don't seem to have a C# version at all here. So what we probably will do is we'll leave it set to invalid, I guess, because I don't think in C# there's a C# version yet. But hopefully none of this will be a problem, because in the future these versions will be data driven, and when we declare the technical space it would come with the version. So we just need to get ourselves to the next hurdle. Right, so now we have a technical space version. We can go to the logical model and say, well, since you must have a technical space, here we are, all technical spaces, there must be a output technical space, input technical space, and then again, to continue our hack, we'll just call this technical space version of the technical space we are targeting. So as I said, this is really completely not ideal, but just have to close our eyes for a little bit. One thing I'm learning with all these refactors is that the intermediate refactors are quite hard to do, because sometimes intermediate stages are quite well, I wouldn't say offensive, but they really are not what you want. But we must always remember that our goal is the end destination, not the middle destination. So we just have to put up with these intermediate steps just to get us closer to the end quicker. That's the key. And since we're here, we probably already have a technical space transform. Here we are, and we will just reuse that, and I should think we will have a very simple Cpt Standard Expander. Okay, cool. So that should get us there, I should think. Let's make sure we're running with latest of everything. Clearly not. Are we compiling debug? No. Let's move back to release. Okay, nothing to do. Perfect. Oh, interesting. We forgot to give it the right type. Also, it's probably questionable whether this thing really is belongs in an identity, but what do we say? Exception. Interesting. What we really meant to say was enumeration. Right, and of course the other problem is going to be quite clearly that we did not namespace correctly the type. Always takes us a little while to warm up. After a while without coding, a few hours. Right, here we are. So the usual now, convert, we have to do two conversions, so convert Dogen, logical, actually let's start with identification. Not exactly the best of names, so long identification, but there you are. And same for logical. Now then, this should be fairly trivial. We don't really expect any breakage, so we forgot to clock. Not quite sure how long we've been coding for. Let's call it 30 maybe. Now then, let's see what the tests say. whilst that's going, let's have a quick look at what the Cpp Standard Expander. I should think this is going to be fairly trivial. So as you can see here, all we're doing is reading a string. Okay, right, so one thing we do need to do, which we have not done, is we need some feature of some kind. And since we are generating code, right, there we are. So I feel very tempted to actually just declare. We probably should call this technical space version, shouldn't we really? This is where we have to decide how far we want to go in terms of hackery. I could actually give this the right name, something like technical space version. And put it in the right place. So let's see what we did. What did we do a second ago when we had to deal with streaming properties? Because these are C++ specific. So did we place them in? Yeah, we did place them in C++. Okay. Right. Okay. Not ideal, but actually, let's just commit what we got because tests are passing. So in fact, let's not commit everything in one go. I do like my nice little isolated commits. You can see here we have two changes, one in the logical model, the other in the identification. So add enumeration for technical space version, and then a second commit is the logical change. Adds technical space version to model. And now what we'll do is we will create a feature for this, or a feature bundle should I say. And perhaps actually I wonder if we already have something for technical spaces. Of course we won't be able to reuse that because the technical spaces are correctly placed in somewhere like MASD.physical, interestingly. Yeah, this is all extremely messy. I'm just going to ignore all of this and just say technical space version or something like that. I mean, it's really in the realms of making things up as you go along at the moment. Doesn't really matter as long as we proceed. Right, so there's the technical space version. Now what we need to do is need to make sure this guy matches what this guy says. Bit of noise from downstairs. Bear with me. See what we're doing here now is we're just copying across the feature. In the future, of course, this feature will be the version of technical space, and it will be something like MASD.logical, I guess, or MASD.physical, I'm not sure. But we don't have to worry about it because when we get to the data-driven part, we'll have to address all of this. So for now, all we need is to move this to the right place so we can get rid of formatables. And also, let's just make sure actually, to be honest, all we need from here is this guy. And that now becomes MASD.cpp, that's fine. So this will generate exactly the same feature as this guy, so you'll have to remove this guy. As you can see, this is going really in the right direction because we almost have no features left, and we have very few types left in Formatables, so it is long, but we are doing the right things, hopefully. So if we just do a generation and the usual conversions, and something like this. Now just have to. Oh, interesting. Logical does not seem to have changed. Have we not saved logical? Slightly confused here actually. I thought we added a feature in the logical model. Well, we certainly removed the feature, and we seem to have generated a feature. I think we didn't convert the logical model somehow. Well, yeah, that has to be the only explanation for this. Ah, there we are, a bit better. So, if I just get rid of that, and that. So if we've done our job properly, this should not break anything. We just generated a feature that in the past was done elsewhere. And the hope is that nothing will break. This is a good thing as well. You probably noticed as well that we spend very little time looking at the generated code now. I guess it's because we're using the code generator for such a long time. But that's a good thing, because it means that generated code has reached some kind of, well, sufficient stability, I guess. This is what we hope for in the future. That I mean, we do want people to look at the generated code if they want to, but ideally they don't have to. So we could say something like logical text.cpp move technical space version to logical model. In fact, I'll just use that. There we are. Right, okay, so now then, we have the version, and it is being read correctly, which is good. I wonder if we should, sadly the OCD in me annoys, when things are not lined up, it annoys me. I think with graphical models is that, and generated graphical models, you could literally spend all of your life playing with it, I think. Also question why is that at the top one, doesn't really matter. Okay, cool. Now then, let's have a quick look at that technical spaces transform. See if this is a suitable place for the version. Yeah, seems innocent enough, I guess. Oh, interesting. We are doing a traversal here with just a lambda. Oh, that's very interesting actually, because just a second ago when we were doing the streaming properties, we ended up creating a class that was fairly trivial. Could have used a lambda for this actually. Would have probably been slightly more sensible. Okay, well, nevertheless. This is going to annoy me now because really there's a lot of boilerplate here for no reason. In fact, sorry, I'm just a bit too annoyed with this. I'm going to have to do something about it. So I wonder if I can just do something like and that could be a static, and we could simply see if we do something like this. Now, course, this guy as a result. The lambda will. It's one of those distractions you always get, isn't it? I mean, we didn't have to do this, but now that I've started doing it. So if I had the lambda, then how would this work? You need to capture some state here. Well, let's just start by quite a lot of noise downstairs. Hopefully, not making it through. Right, so say we got something like this. Now, of course, we will need all these guys. I mean, process is an awful name, but you get what we're trying to say here. Feature group by reference, should be by reference anyway. Logical ID, this will now be identification. Entities, logical ID. Result. In fact, now you can see that perhaps what we're trying to do here is not quite the same thing, really. So now what we could say is, right, so this starts to make a bit more sense. Now, I am 100% sure we shouldn't really be wasting time on all of this, but there you are. So all the job of the thing here should just be to read the properties, generate the streaming properties. Yeah, now this is making a bit more sense. So if you have something like whatever streaming properties live, entities perhaps. This is a great example of how programmers are never quite happy with anything. You do something and then soon enough you remember some variation that can make things slightly more interesting, and then you end up wasting time on that. So there we are. So we need the features. Read streaming properties. Supply with a feature group. We won't supply with the results. We'll supply with an element. Seems fair enough. So this guy will just return us the streaming properties, right? And then the lambda, which we'll have here, which has to match the interface that this guy is expecting. Bit of side destruction here, but now what we'll do with the lambda is we will make sure that this lambda is capturing the existing state. And we can do something like this. So for each element that we go through, we just need to call. Actually, we must remember that we haven't updated this method. Now you could probably argue whether we should just not waste time doing this sort of stuff. I would not disagree that this is probably not required and just wasting a bit of time here. But sometimes you have to do things because you find it fun. So there we are. Streaming properties. Blah blah blah. So we're getting a feature group. So this guy returns streaming properties. It's called read streaming properties. Takes a feature group, takes an element, and then not entirely sure why it's moaning about element. That should be fine. Takes the feature group. To be fair, we don't really need the long name now because we know exactly what this is. No need to make things verbose. Now, I'm not really sure. declare because there's nothing close. One thing we should probably take into account is the fact that we now don't need all of this stuff. See, as you can see here, a lot of the boilerplate just goes away. There's no need for all that stuff. This is taking up space, just noise. We don't want noise. Like Kevlin Henny always says, you should make each line count. If there's lots of noise, it just makes it harder to read what it is they're trying to do. Now, as you can see here, we may not have streaming properties, so that's fine. We just have to make it optional. And what we'll do is we'll make this guy optional. Very nice. However, put it in the wrong place. I must say, getting clever as LSP. We can just say, just return the empty optional. Otherwise, create the real thing. Now, the clever bit is we don't bother with all of this. Right, so this guy here is just responsible for doing the reading. This guy here does the following. It says, please read or obtain or create the streaming properties. So if we just call these const auto O, because it's going to be an optional, O the E, and then if O, we create a pair with the O and the e.name.id, which we probably want to create an auto for. Right, and then we just basically insert and if we didn't insert, there's something gone wrong. And there you are. This makes me slightly happier. Finally slot that into the model. Right, that's good. And now, because we're reading the streaming properties, we will probably have to supply something like FG. And yeah, so you can see here, this looks slightly better, doesn't it, really? Because we had all that boilerplate with the gatherer and blah-de-blah-de-blah, all sorts of stuff going on. But in reality, really what we wanted was some guy that does the reading of the streaming properties, and then some guy that does the processing, well, the slotting in of the properties. So this looks good, and one thing I like to do, I think you should probably not do this really. Again, Kevin always says you should try to do structured programming. I always feel tempted to try to preserve my columns for whatever reason, and I do early returns a lot. It just seems to make the code slightly easier on the eye somehow. So now you can see what we're doing here. We're just basically saying, to be fair, really, one annoying thing at the moment is this having Emacs. This should be the right indentation, but if I do that, then Emacs goes a little bit crazy. So nothing I can do. So hopefully this is equivalent to what we were doing before, just with less boilerplate, I think. We'd forgotten that we could use lambdas with the traversal, actually. Sometimes you just haven't touched things for a while. Let's see what the tests say. There you are, completely equivalent. But you can see, however, how much less code. This is much nicer. Right, so let's say something like logical use lambdas, use lambda in streaming properties, transform instead of class, of helper class. Too big. Maybe just helper. Okay, that made me slightly happier. Bit of a detour. Where are we then? So we were looking at that lambda, and we have a similar. Well, what we really want to look at is the Cpp Standard Expander. Now, what this guy is doing is all sorts of nonsense here. But really, the gist of it is we're going to read a string. We're going to convert it to one of our enumerations, and then we're going to slot that enumeration somewhere in the model. So I should think we probably should just create a. Let's start with the include, I guess. And then we can have a. Well, almost nothing in common to that method, to be honest. So, oops, daisy. How are we doing for time? Half an hour. So if we say something like this, identification, entities, technical space version to technical space version constitutes string. This could be a static. Right, so not sure why Emacs is not liking the syntax here. But there you go, that's fine. And then if we in the method itself, we just need to do a copy and paste job from here. Interesting. What we meant to do is put it here. And this guy will just simply do something like this. Now, it is possible, well actually no, we will have an invalid standard. If it's supplied, it has to be valid. I think I know what the problem was in Emacs. We just forgot to put things properly. Right, so if the string, now all we need to do is something like this guy, which then allows us to just return this guy. One thing I don't understand is sometimes you can't, you don't seem to be able to use the clipboard manager inside of the mini buffer in Emacs for some reason. It's quite annoying. And there we will hopefully have an exception somewhere. There we are. Transformation error. I don't know why you don't call it transform error, but there you go. Right, so very, very simple. And then we need, if we just go up to the string properties transform, we need something almost identical to this, except it's called technical space version. And then if I just look for feature, and right here we can now say read the technical space version. Will be something like this. Do I have a context? We must do it a transform, and now in here we want to say something like technical space version, presumably. This will generate the feature group, so everyone's happy. Now with the feature group, presumably we already have FM somewhere. We already have a feature group too, so I'm just going to call that. Actually, let's just use an LSP rename. I wonder if the rename will work since we have an error. So if I just do an LSP rename, let's call this feature group 1. And then I'll call this feature group 2. These variables are so short-lived and so scoped that we don't really care about their names, as long as we know more or less what they do. And then we need something like this. So we will make the static configuration. So if I just do it using here. Oh, I think I may have using technical space version above. There's gonna be a clash here. Don't think I can do using of two things to the same name. Yeah, this is just going to cause us problems. To be honest, I am beginning to think that we are doing too many things in one method here. Let's just stop to think for a second. What is this method doing? So we have the input technical spaces. I think there's 3 different things we're doing here. We have the intrinsic technical space, we have the input technical space, we have the output technical space. And look what's happening here. Early return. Right, this is really... So I think we're definitely confusing ourselves slightly here. So let's just... convert string into the... enumeration presentation. Actually, we don't even need to do this because we already have a method to do that, funnily enough. Just remembered, we can lexical cast strings unless there is something special about this. So C++. Oh yes, this is not going to work simply because we have ++. So if it was CPP, probably would have worked. C++ is not a valid enumeration, so there is no direct mapping between the two. Right, so let's say we do something like this. Processes, technical spaces. I don't know, I'm not very creative with names at the moment, but something like this, and then instead of apply we call I don't know, handles technical space related attributes. And here we could call this something like read, I don't know, what would you call this method? Process. I'm really not very creative at this point in time. Brain still not properly functioning. So let's not make too much of a meal out of this. So we're just going to break that slightly long-winded method into 2. And the first one will be... I could probably break into more than 2, but I'm just going to go for 2 for now. Because I think there is already some kind of logic to all these things. They seem to belong together somehow. Now let's just make sure that by doing this, things like the tracer not affected. Okay, good. And then this guy will now handle the technical space part of the work. Just have to call it. And there will be a methods that will be almost identical with the job of process doing technical space version. Handles the version of the technical space. Slightly less hacky. I mean, the key thing to remember, and this is one thing I always tell myself when I'm doing programming, there is no such thing as perfect code, really. I mean, not everyone is going to be Linus Torvalds and so on. So sometimes all you need to do is make it less bad. Looks like some comms coming from downstairs. Where are we then? Yeah, so now then, we can take that ugly name that we had a second ago to another SP rename it to just FG. And this guy here now can just be FG. And hopefully, bit of luck. So, we need a configuration as well. Presumably from the root module. Right. I'm just going to make a slightly shorter version of this. Solves two problems. So you guys still being called up. Right, sorry for that. Where are we then? So what are we doing is we are just going to read. Well, now it should be very straightforward, I guess. We probably have a default value. Okay. This is where things are interesting. So what we did in the past is we defaulted. It just depends how much hackery you want to do here, really. We defaulted in the past to C++ 14. Now, of course, you can imagine it's very less than ideal to have a C# model whose technical version is C++ 14. So, I mean, we are hacking, but I guess there are limits to the hackery. So, that's maybe one hack too far. I guess this is not particularly useful comment. Maybe. Fields, attributes. I haven't quite got my head around the right level of commentary. So we probably should just have a quick look at, say, the output technical space, I guess. And there's multiple of these as well. I think what we should do is we should we're going to do the same hack as we did here, which is if there is no configuration point, so we're just going to go to the selector. And just like we did here, we're going to detect the presence of the configuration point. So if the point does not exist, we just will do nothing. And otherwise we will well, we could, let's see, can we do this in one go? Might be a bit too much. Technical space, yeah, this is definitely going to be too much, isn't it? So maybe const auto V for version, to technical space version, cfg dot standard. So if the configuration point does not exist, then don't do anything. If it does exist, get us the configuration point. Oh, now I'm actually tempted to see if this fits. And there we are. Okay, that seems fairly straightforward. Now let's see what happens if we try to run this. So let's make sure we are recording. Too much stop and start today. Right, so if all has gone well, hopefully we would be reading the technical space version now. And then, okay, that seems to have worked. Now, what is going to be a little bit more annoying is, as if you remember, we don't really have a full model here. We have a Formatables model, the thing that we're trying to get rid of. So we need somehow to propagate the version. Let's just see how this C++. This is always what happens. We always come up with something really simple to do, and then 5 seconds later we figure out that actually there are problems. Let's just RG Cpp Standard and see how this guy is being used. So this is the assistant, presumably. Yeah, so the assistant is using the mod. So I think what we're gonna do is we're gonna yet again hack the context, because it's just the easier way to get this information to the assistant. So if I just look at the assistant, this guy here is gonna have, yeah, exactly. So what the assistant is doing is he's querying the context in the model in the context. Now, you can't really do that. So what we do is we will go to this guy here. His context is becoming a little bit big, but there we are. So we take the technical space version and we will slot it into the context. Perhaps just next to simming properties. So probably const, and if we just say something like this, and as always we need some kind of way to get it out, so something like this. Probably don't need the consts, I don't think. Right, now then, what does all of this mean? We can just go to the context of CPP. And just here. Righty. You can see this is very, very straightforward. Not pretty, but hopefully it'll do the job. We are actually rather close to being able to generate this context. I think the only reason why is just the helpers. I still don't think we should spend the time on this now, but it would be nice not to have to write all this pretty repetitive and redundant code. Right, so there we are, and then if we try to run this, what's going to happen is it's going to give us a loady error. Now I think the problem we're going to have is, in order to get to the context, we need to go via a couple of workflows, I think. So whilst the compilation is going, let's just start to think about it. The first thing is going to be, we need the transforms workflow, I should think. And this guy here will have a context somewhere. There it is. Now the question is, does this guy have access to a real model? And it doesn't. So what we've done, is we have passed in all these properties via the constructor of the transform. It's all very ugly, but we'll have to do for now. Really is rather unnecessary, all this madness, but we need to do that because for now this is the easiest way. Right, so in here we need something like ESV. And then if we just initialize this guy. So the reason why we need to do all this sort of madness is because we still have these workflows, and there is no easy way to so at the moment, really, let me just give you a little bit of an explanation of what's going on here and why this is so bad. So at the moment we have this top level chain, which to be fair is what it should be there really. On this chain, the responsibility of this chain should really be to run the text transforms. So in an ideal world, we would merge this guy with this guy, and simply all it should do is should take a model, a logical physical model, and it for each element should call the transform. That should be its job. However, because of in the past we had the whole notion of formatables, we now have two workflows, one for formatables and one for transforms. And because of that, we now have to drill through these workflows in order to get the data in the right place. This is all historical, and we just have to deal with it until we refactor all this really bad code. What is this error now? I'm not very sure. Let's just run this again. So now the chain is going to moan. Okay, that's what you'd expect. So you can see what's going on here now. We're just drilling through the layers to try to get our information in the right place with the right shape. You just have to literally bear with us whilst we do all this nasty stuff. And hopefully around here somewhere life will be good. Right now do a const auto tsv, and it should be as simple as m.logical, not technical space version. And there you are. Not quite sure where this is going to go, but somewhere around here. Right, so hopefully what this now is giving us is, okay, not what we want. Now that's interesting. Did we made a mistake here somewhere? I think we might have done the wrong method. I'm not even sure why we're supplying the streaming properties to the Formatables model anymore, if I'm honest. Let's just let's have a very, very quick look at what the Formatables workflow is doing. Okay, the model expander seems to still need the streaming properties. Oh, okay, right. Okay, fine. Let's not get confused. It's just because he's used somewhere else in the helpers. Right, there's always a reason for things. Right, no, not you. You. Okay, our objective is at this point in time just to drill through all the layers and make sure that we're getting the data to the right places. probably approaching an hour. Once we've done that, we probably can commit. I don't think we've done any modeling changes, so I'm not gonna. I'll just commit that independently. So the tests are passing, so I don't know what this is, but I'm just gonna say logical cosmetic changes to model. Models. Logical model. Just so we don't have diffs, spurious diffs coming up. So now what we're gonna do is oh, actually we have two different things changing here. So, right, there's two changes. Let's just do this one at a time. So, I think what we're trying to do here is something like logical implement technical space version. So read technical space version in technical space transform. Okay. And then in here we want to say text.cpp supply technical space version to context. Okay, so that guy there basically gives us the technical space version where we want it. And now, finally, what we want to do is to see what happens when we remove well, I actually think, believe it or not, that we could probably just change one bit of code, which is the assistant. Because I think it's all encapsulated in here by some kind of magic. So I think we could probably get away with something like, let's say, yeah, there's no mention of the words. Yeah, we're not mentioning the standard itself. So I think we could do something like this. Let's just look for where these guys are used. So if I say something like this, we probably need the using first, I guess. So so if we just use this guy, and then if we just do a Cpt Standard this, and now, believe it or not, if everything is gone according to plan, I'm sure it won't, but we could do something like, you can see we're making a line that's a bit too big, so it's another of my OCDs that I don't really like lines that are greater than maximum length. This makes it harder to read. So I wonder if I wonder if this is actually the only thing we need to do. That'll be quite hilarious if it is. No other changes. How are we doing for time? For some reason GNOME now doesn't update the clock. Okay. There we are. That actually worked. So if we now say something like text.cpp replace Cpt Standards with technical space version, and since everything is still green, let's make sure we're running the latest. Now, with a bit of luck, we should be able to start removing things. So I would start off by removing this guy here. And to be fair, I mean, let's just go big and move this guy too. And then, if we just generate this, should just get a few changes. Let's just convert text to JSON. We should really honestly automate this. I don't know why I keep typing the same thing on and on and on. But there you are. So let's see what the errors now tell us. So one would expect, okay, the transform itself needs to go. That was a bit of a mistake. Just deleted the whole namespace. So we want to do that, but not so easy. Let's just double check that's the only thing that changed. That's good. One good thing about JSON for all of its problems is that at least it gives us a quick way of knowing if we just change one thing. Okay, let's just regenerate that model. Run the tests. Now we got the error we expected. So model expander. Let's make sure that Cpp is not here. And then in here, there we are. So standard. And there we are. Bit slow, annoyingly. Okay, that's interesting. I actually think this whole comment is completely meaningless because I don't think we even do that anymore. Well, you should, but I don't think we do. Let's have a quick look. Okay, right, so now we don't need this guy anymore. Presumably that's going to cause some more havoc. So let's just keep in mind we need to check. So where are we then? Transform workflow. No, I think it's the other workflow. Must be the Formatables workflow, of course. Right, so what is going on here then? So in the Formatables workflow, we don't really need this guy. Righty. Okay. Oh. I think I forgot to delete that guy. SPE is struggling a little bit for some reason. Right, so now we expect the main transform to fail. And it does. And we just need to do exactly the same thing here. So it's almost like we're switching the lights off of Formatables one by one. It's quite nice, if somewhat slow. And now I guess we'll have one more error. Right, so hopefully, and this will probably be a good point to end this video, hopefully we would have done the C++ standard. So while that compilation is going on, we'll just quickly recap what we did. So we had a way to represent the different versions of C++ in formatables. Again, as I've said a few times, formatables is all the legacy stuff where we didn't really know what we were doing, so we just hard-coded a whole load of stuff. The right way of doing this is, of course, to have some kind of data-driven representation. The idea being that when you define the physical meta model and you define the backend should have a property which is the technical space in the technical space version. Technical space itself should also be a meta modeling element, and that's kind of where we're heading towards. We created an in-between state which allows us to move away from formatables, which is not really that data-driven world, but is also not the hackery of formatables, somewhere in between. And for that, what we did is we baked in the technical spaces in the technical space versions as enums, and we just copied all the logic that we had to read the technical space version as metadata from the model and place it into the logical model representation. Because it's fairly connected to the technical space, we updated the existing technical space transform to do that reading there. And with that, we now managed to get rid of a whole lot of infrastructure informatables, and the tests are now green. And the code generator, well, let's make sure we staged everything before we do that. The code generator is still generating correctly. So let's just call these remove Cpp standards from formatables. And there we are. So this is all for this video. Just roughly managed to stick to about an hour. Okay, cool. So that's yet another element that was done in this refactoring. And what we'll do is for the next video, we shall tackle test data properties, I believe. We have the test data properties. We have the aspect properties, and I think those are all the loose ones. If I'm not mistaken. And then finally we just have the helpers, which has to be done all in one go. So let's just clock out. And let's just add a note here for the next guy we're going to look into. That was fairly successful, I think. Finally we did a whole refactor in the video. And as you can see, we are approaching the end of sprint. We normally close sprints when we get to about 80 hours, so we have a nice rounded amount of work in the sprint. And we'll just push all of this stuff to all of our remotes, which will kick off a build. Okay, that's it for this video. Thanks for watching.